First question that we have over here is limit of this function as the theta approaches 0. So first test is to make sure that you put the value at the denominator. If you put that 0 at the denominator, it is going to make the denominator 0, which shouldn't be the case, right? Which is not normal. So we need to actually look at another method because this is a sine function, right? So if there is sine, you need to be looking at a way to have a form, to fetch a form that is in this way: limit as x approaches 0 of sine x all over x. This is equal to 1. So you need to try to get a format like this out of whatever you have if it contains sine function after trying the direct substitution. That's basically putting the value at the denominator. So you need to make sure that this guy is the same as this guy. So in this case, it's straightforward, right? So you have 2 multiplying the top. So this one can be like 2 multiplying limit as theta approaches 0 of the sine of square root of 9 theta all over square root of 9 theta. Already, this side, this is the same as this, right? So it's looking like this our function here as a sinc function. So this whole thing here will now be 1. So at the end of the day, you just have 2 times 1, and the answer is just 2. Yes, so the limit for this value is just simply 2. We have this other question as well. Here, we are having a formula 19y over 7y, but then we need to make sure that the denominator is having the same thing like these guys, right? So what I can do here is that here you have to actually go a bit above the lower level where you try to make the denominator the same as that of the numerator without actually changing. So 19y is over here, right? Let me put this in bracket nicely. And so 7y is already in the denominator. What can I do to make? I can multiply this by 19 over 7, right? So that 7 will cancel it, then we get to add 90. 90 will multiply y. So it will look the same as this thing. But because we multiply the denominator by a particular factor, we need to account for that one as well by multiplying the numerator by that same factor. At the end of the day, this will cancel this, right? This will cancel this at the denominator. Then you have 19 over 7. That's this numerator one that is left times limit as y approaches 0 of sine 19y over 19y now. And this whole thing will just be 1. So at the end of the day, we just have 19 over 7 times 1. So the answer is 19 over 7. So the trick around this is that if you have a format like this, right? Sine 19y over this. You have a format like that. Just make sure that you just use this over this. Okay, 19y over 7y, then you get your answer. At the end of the day, you should make sure that the variable finally simplify before you can do that. So generally, we know that we usually have sine x over x, right? If you have this format, the shortcut is that just use this over this, then you have 1 over 1, then which is 1. So that's usually what we have. This is just a shortcut. Doesn't mean that that's a basic concept, but it works. But you have to make sure that when you divide this by this, right, you get a constant. Then it should be in this form and sine something over 7y, or like having a factor, right, containing the variable that's here. So here is basically 19 over 7. That's if you are working in section A, right? The answer is 19 over 7. Okay. Yeah, that's the trick. So we'll use that somewhere in the future. So like this one is tan. I forgot to also mention that tan works the same way as the sine. So there's a proof to that. There's a proof that we can basically do to do that. But then let me just tell you that when you have ln of tan of x over x, right, as x approaches 0, is the same answer. It is also equal to 1. We have to keep it in mind. It worked for sine and it went for cos. But how is it so? I'm going to prove just this, right, before you come back to our answer. Let me clean this thing. Why is it so? So the reason why it's so is because tan is equal to what? Tan s is equal to sine s over cos x. So if you put that in here, you are going to have, so tan s over x will be the same as sine x over cos x. So there is this s multiplying, right? So this one can also, so you can separate this. You can separate it to have sine x over x multiplying 1 over cos x, right? This is what you will have. And you know that the limit as this thing is equal to 1, right? And then that of cos, right? Cos 0 is 1. Because if you put 0 inside the cos 0 is equal to 1. Let's keep that in mind. Cos 0 is equal to 1. At the end of the day, you have 1 over 1, which is 1 times 1. So the answer is 1. So when you have tan, right, tan weight the same way as the sine and tan. But the major thing is because tan contains sine somewhere, and eventually they come out to be 1. That's why. So this particular expression is also becoming 1 because it contains sine, which also simplifies like that. So if you do the same thing here, right, for this particular thing, you will try to make the denominator the same as the argument in front of the term function, so that the denominator is the same as that particular value. So what do? We need to make sure that the denominator becomes this. So I'm going to stop. I'll stop writing this limit because it's the same thing everywhere. So I'll just be focusing on this one. So what do I have? I will have tan 3x all over. How do I get a 3x as a divisor? I need to multiply by 3, right? But I need to multiply the top by 3 as well in order to counter this particular factor that you have introduced. At the end of the day, you have this particular component, right, equal to 1 because of now you have made this one the same as this. So this whole thing will now be 1. So at the end of the day, you have 3 times 1, which is equal to 3. If you want to use the shortcut that we use, yes, of course, it works over here as well. We just basically use this. If you have this format, whether here is sine or tan, right? You use this format, you have 3x over x, which is just equal to 3. And that's your answer. I hope you are good with that. Okay. Now let's try um other examples. I have this example first. Sine 5x over sine 4x. What will be the answer? So what we have to do is that I will I want to first note this. I want you to note this, that if you have sine x over x, then so you can write the limit in here. I say I'll just stop writing the limit because it just takes my time, right? So what if you have this is equal to 1, right? This is 1 is the same as 1 over 1, right? So if you find the reciprocal of this is the same going to be 1, meaning that I'm just saying that if you now have x over sine x and you have the limit whatever, right, is going to also be equal to 1 because you are just basically reciprocal of 1 is 1 itself, right? So this is something that you need to keep in mind when approaching this kind of questions. So if you find the reciprocal of it as well, it's the same thing. So let's look at how to solve this one. So we need to make sure that we have a factor in the numerator. Factor in the numerator that will in the denominator that will make this guy have a same. So what I will do is that I'll do sine 5x all over 5x, right, times sine 4x. We are introducing this sine 5x because we want it to look the same as the one for the numerator, right? But then we have to also do the same thing for what we're having here, but we can have it at the numerator here to make sure that you can introduce something at the numerator here so that it will be the same as this guy. So if I do that, I will have 4x sine 5x. No, before you even do that, you didn't complete doing this. See, when you introduce this 5x at the denominator here, right, it's something we are introducing, so you need to make sure that we write it on both numerator and numerator just to make sure that this one gets back to this, right? You needed to make sure of that so that this one can be equal. We are introducing it so the numerator and denominator should have the same factor that is multiplying to keep the fraction constant. So now we need to actually do it for this guy as well. To do it for this guy, you need to multiply the numerator. So I'll have 4x, right, multiplying 5x that you have introduced already, sine 5x all over 5x. Then let me write the 4x first because that's what we are introducing. So let me write 4x times 5x multiplying sine 4x. So now this is what I introduced the second time. The first time I introduced this one to make sure that this one has a denominator that's having this component. This one, to focus on this one in this section where I try to introduce the 4x at the top, right, which is here, and then 4x at the top so that it will have is the same argument as this over here, and I'll have this one is 5x. I have it over here. But you need to this repetition at the top and numerator is because you want to keep the fraction the same, right? So if you have this now, you can separate this. You have separate this that in such a way that everybody has their own denominator and numerators. For example, sine 5x, right? So I can basically just have um 5 5x sine 5x all over 5x, right? Multiplying 4x over 4x multiplying sine x sine 4x. I just separated this thing. So now I can see this here. It's multiplication, so it's the same. And I can see this here. You see the sign, whatever is here is the same here, whatever is here is the same here. So this is 1, this is also 1. So if you have this, at the end of the day, you just have 5x multiplying 1, right? Times uh, 1 over 4x multiplying 1, because this 4 is now the denominator. This one is at the top. So if you do this, this will cancel this. At the end of the day, you have 5 over 4. So the limit is basically 5 over 4. Okay? Yeah. The limit is basically 5 over 4. That's how you go through. But then you can see the shortcut, right? If you have sine over sine and you are finding the limit and you have a situation like this, right? Just basically do this. 5 over 4. Or you can just take the same shortcut. 5x over 4x. Then you have 5 over 4. This is the answer for this particular question. But then to go to the step, that's what we did originally. Okay. Now, what of this case? Is it going to be the same thing? Is it going to be the same thing? Yes, it's going to be the same thing, right? So this is basically going to be 3 over 8. So sine, I told you that sine works the same way as what? Sine. Tan works the same way as when it comes to limit as x approaches 0, right? It works the same way as that. So basically, when you do that, when you have a situation like this, you have to know that the answer is just what? 3 over 8, 3 over 8, like how we did for previously. So I challenge you to continue to break this one and actually see how it's done, right? In order the step by for session is, right? Just basically quickly have that for yourself and choose the right answer quickly to get the limits of such trigonometric functions. Let's increase the thing, right? It's not really, let's increase the difficulty, but it's not really difficult over here, but we just need some of your one basic thing. So I will simplify the numerator, right? I will not be writing this thing. I will not be writing it. So keep that in mind. But you have to be writing it when you are actually. I will factorize 11x out for the numerator. I have 1 plus cos 11x. I'm factorizing. So this 11x is an argument. Remember, I'm just factorizing this 11x out. Okay, it's an argument. So you can factorize and be keeping this one out too. It doesn't happen. So at the end of the day, I have it over 8 sine 11x cos 11x. Have you seen something? We can find that the argument for sine, right, is the same as this guy. Do you see that? So me, this thing, right, becomes 1. This thing becomes 1. At the end of the day, you just have 1 plus cos 11x all over 8 cos 11x. Now we are done simplifying. There's no sign thing. So what do we have to do? We now need to put in the value of x, right? Cos doesn't follow this. The sign as x approaches 0 is 0 is 1. So as x approaches 0, if you put a 0 inside directly, you are not going to get a 0 at the denominator. So if you put 0 over here, cos 11 times 0 is going to be like cos 0 is 1. Cos 0 is 1. Let me write it here again. Cos of 0 is equal to 1. So if you put this 0 inside this, right, you're going to have cos 0 here, cos 0 here. So it's 1 plus 1. So 1 plus 1 is going to be 2 at the numerator, and 8 times 1 is going to be 8. That will basically give us 1 over 4. So this is the limit for this particular question. Yes. So I hope we have learned a lot of tricks over here. The trick doesn't work for this one. All you have to be careful by looking at how you can be able to actually simplify to in order to always try to be looking at a case like this. You manipulate in such a way that you have a case where the argument of the sine function is the same as at the numerator of the denominator of it, right? You basically just have that, and that you'll be fine. So we are yes. So this is some of the questions that you solve, right? We will move to the another concept in the future video, in the subsequent videos, right? Stay in touch, subscribe. Let's see how to master and strengthen our calculus.